We're going to be taking the square root of things today. What's a radical? What does it do? Well, it's that symbol right there in blue. It's a square root thing. And I hope that you've seen these. Square root of 4 is 2. Square root of 36 is 6. 10. I think that's 15. And really, what you're asking yourself is, what times itself would give me 4? What times itself would give me 36? What times itself would give me 100? And that's what the square root is. So those are easy, but 248 aren't as convenient as those because they're not perfect squares. So we're going to have to simplify them. I've written some rules down there as to what makes a simplified radical. So I have square root of 50. Step 1, create a list of all the perfect squares. Check. I've got our list of perfect squares down there, and I've got step 2 written up here. Find the largest perfect square that goes into that number. So I've got all these numbers, like 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, so on and so forth. That's how I got those numbers. We want to find the largest perfect square that goes into this 50 right here. The largest perfect square, if I didn't know, I'd have my calculator maybe and start dividing, figure out which one of those numbers would go into it. And it is 25. 25 times 2. I think that's going to lead us to our step 3. So I'm going to rewrite this as 25 times 2 under there. And we can rewrite that as square root of 25 times the square root of 2, which is 5 square root of 2. That is your simplified radical. So let's look at an example here. Square root of 32. I got all my steps for you over there on the right side. Largest perfect square that goes into 32. I'm thinking, 1, 4, 9. 16 is the largest perfect square that will go into 32. So I'm going to separate those. Square root of 16 times the square root of 2. And the square root of 16 is one of those nice numbers. So my final answer is 4 square root of 2. 48. What's the largest perfect square that goes into 48? I would take all those perfect square numbers and start dividing. That number would be 16 again. And that is 16 times 3. Separate them. 16, square root of 16 times square root of 3. Square root of 16 is 4. And square root of 3 cannot be simplified any further. Square root of 8. Sorry, this was easy. Largest perfect square that goes into 8. 4 times 2. I can separate those into square root of 4, square root of 2. That would be 2 square root of 2, just like that. Largest perfect square that goes into 200 is the easy one. 100 times 2. I separate them. Square root of 100 times the square root of 2. Square root of 100 is 10. That's the square root of 2. Got some more practice here. Square root of 75. 75, largest perfect square. It's going to be 25 times 3. You can separate that into square root of 25 and square root of 3. That is just 5 square root of 3. Something similar with 125. Square root of 24. Large perfect square that goes into 24 would be 4. Square root of 4 times the square root of 6. Square root of 4 is 2. Can't simplify square root of 6 any further. 500. You try that one. Push pause, try. It'd be 100 times 5. Square root of 100 times square root of 5. That's 10. Square root of 5. Largest perfect square that goes into 72. The answer for that is 36, but oftentimes students will write it like this. They'll say, oh, it's 9 times 8. And then they'll separate and get square root of 9, square root of 8. That's 3 square root of 8. But there's a perfect square that goes into 8. So then I could rewrite that as 3 square root of 4 times 2. So then that's 3 times 2 square root of 2. I think my answer is 6 square root of 2. And if I had just started with square root of 36 times 2, that's 6, and then square root of 2. Get the same answer either way. (28), largest perfect square that goes into 28. 4 times 7, that's square root of 4, times square root of 7, that's 2 square root of 7. Leaving some of these for you to practice. So, simplifying radicals, when we rewrite radicals like square root of 9, we say to ourselves, what times itself would give us 9? So obviously that's 3 times 3. What times itself would give us 4? It's 2 times 2. 25 would be 5 times 5. 7 times 7 would give us 49. 4 times 4 would give us 16. But what about variables? We got square root of x to the 10th here. Do those things have square roots? They do. Spoiler alert. What times itself would give us x squared? X times x. Remember, you add these exponents right here. So x times x would give us x squared. What times itself would give us x to the 8th? X to the 4th times x to the 4th. X to the 6th? X to the 3rd times x to the 3rd. X to the 10th? Be x to the 5th times x to the 5th. And so instead of saying, 2 times 2 gives us 4, we could say, what's the square root of 4? Well, that's 2, because 2 times itself gives us 4. What's the square root of 49? 7, because 7 times 7 is 49. Well, what's the square root of x to the 6th? Well, it's x to the 3rd, because x to the 3rd times itself gives me x to the 6th. So if I'm looking right here, x squared, what times itself gives me x squared? X. M to the 4th, what times itself would give me m to the 4th? M squared. What times itself would give me x to the 14th? Would be x to the 7th. Is an easy one thrown in there. 5. If you notice, all of these are even exponents. So on each of these, I'm just cutting them in half. So this would be t to the 5th. This would be y to the 11th. What times itself would give us those numbers? Those are all even exponents. That's nice and easy. You could do this. Square root of x to the 8th would be x to the 4th. But the problem comes in when there's an odd exponent. So sometimes we have odd exponents, and you have to treat it just like these non-perfect squares, just like we did square root of 50. So I rewrote square root of 50 with its largest perfect square. That's 25 times 2. And then I said square root of 25 times square root of 2. That would be 5 square root of 2. So when I have x to the 5th, what's the largest perfect square that goes into x to the 5th? Well, it's the one right next door to it. It's x to the 4th times x to the 1st. So I could rewrite that as x to the 4th, square root of x to the 4th, times square root of x. And I know the square root of x to the 4th because that's an even exponent. That's x squared, square root of x. X to the 7th, I can rewrite that as x to the 6th times x. Separate it, x to the 6th, square root of x. X to the 6th is an even exponent, so that's x to the 3rd, square root of x. M to the 15th, largest perfect square that goes into m to the 15th would be right next door to it. That's m to the 14th times m to the 1st. And I'm going to separate those, m to the 14th and m. Square root of m to the 14th is m to the 7th. Square root of m is still underneath there. So once again, even exponents, you're going to cut the exponent in half, bring it outside. Odd exponents, you'll subtract one, leave one of the variables inside, and treat the even exponent just like usual. So I have two exponents right here. I've got two variables. So just going to treat it just like I did like the 50. I got 25 and 2. So I'm going to separate these. I got x to the 8th and y to the 6th. I know what the square root of these are because they're both even. This would be x to the 4th and y to the 3rd. So that's the square root of all that stuff up top. When it gets tricky is when I have an odd exponent. So I've got to separate these into t to the 7th and x to the 4th. I'm going to rewrite t to the 7th as t to the 6th times t. Separate it, t to the 6th, square root of t. That would be t to the 3rd, square root of t. And then the square root of x to the 4th, don't forget about it, is x squared. So now I've got to put everything together that's on the outside, and then I got to put everything together that's on the inside. So everything that's on the outside would be t cubed x squared, and then on the inside it's just t would be my final answer. Got numbers now. So I got 25 m to the 7th. Going to separate it. 25 m to the 7th. I know the square root of 25, that's just 5. And m to the 7th, I'm going to rewrite as m to the 6th times m. Separate them. That would be m to the 3rd, square root of m. Everything that's on the outside, I'm going to put it together. 5m to the 3rd, everything on the inside, I'm going to put it together. Last little style of simplifying radicals. I got a number on the outside, so I've got 2. I'm just going to treat it as if it's multiplying something else. 2 times square root of 24 times the square root of x to the 11th. I don't know why I wrote so far to the left into the gray. So 2, I'm probably just going to end up bringing that all the way down. 24, largest perfect square that goes into 24 is 4 times 6. Separate it, that'd be 4 and 6. That is 2 square root of 6. And then x to the 11th, largest perfect square that goes into x to the 11th is x to the 10th times x. Separate that, x to the 10th, square root of x to the 10th times square root of x. X to the 10th, that's an even exponent, so I just cut it in half. That would be x to the 5th, and then I leave that square root of x in there. Don't forget about this 2 right here. And I have to take everything that's together on the outside, put it on the outside, and everything together on the inside, put it on the inside. So on the outside, I'm going to have 2, 2, and x to the 5th. So I'm going to have 2 times 2 is 4, x to the 5th. Everything that's on the inside is 6x.